Alright, and welcome back. Today we are actually going to test this, what do you call this, Aven? Aven? I don't know, Aven. It's a smart SMD tester. And they actually show a picture. It goes for about $40, but they actually show a picture on the back here, I think it is, of testing inline circuit. So I'm to assume this means this can be something that you can test on a circuit board that's inline. We'll find out how true that is. Let's go over some of the specs real quick. Simple specs anyway. There's your resistance accuracy. They're claiming 1% plus 2. Capacitance for anything up to 30 microfarads. They're saying 2.5% plus 3. The display is 3,000 counts. Auto ranging, manual ranging, auto scanning, auto power off. That's kind of annoying sometimes. Diode, 2.7 volt current used to check the diode. Continuity buzzer, anything less than 30 ohms. Low battery display. Runs off of one CR2032 battery, which it does come with. Product size, weighs about 46 grams or 1/10 of an amp, and is a CE certificate approved and ROHS compliant. So, before we do this, we're going to try some off circuit board components here. I have two microfarad capacitors and one 10,000 resistor here, so we can actually test this. So I'm going to try this with my fluke. We'll use the actual fluke leads first and see how this comes out, because we're going to be comparing this supposed inline circuit tweezer tester. I got a board over here ready to go that no parts have been removed from, so I'm actually on capacitance level. So let's go ahead and check that real quick. Whoops. So this one comes to, dang, it keeps slipping. These are really hard to test sometimes. 1.018 microfarad, or we'll call it 1.2 microfarads actually if I hit it again off the board. There we go. This one, again, same rating, 1.11 microfarad. And resistance, this is supposed to be a 10,000 K resistor, 9.85 thousand ohm resistor. So just again, we'll do it one more time. 9.849, 9.850 thousand. Now the alternative to buying a smart SMD tester, tweezer type thing, is to actually get a pair of tweezers that go to banana plugs with gold tips. So let's go ahead and try those and see what kind of readings we get on those with off the circuit. So we'll start with, let me move this around here. There we go. Start with the resistor. And that comes up 9.850, same as the actual probes. So I'm happy with that. And we'll go to the smaller cap here. This is the 805 cap, 1 microfarad. And whoops, apparently I don't have a good connection here. Oh, you know what? That would help if I switch back over to capacitance. Sorry. Trying to read 1.08 microfarad, same as the fluke probes that I got on this one. And this is the 1206, and it's 1.026, and I believe I got 1.018 previously. Let's see if we can do that again. Yeah, so a slight difference there. The smaller one has been about the same as far as the accuracy goes. So let's go ahead and check out these so-called smart SMD testers. I don't know what makes them so smart. I haven't figured that part out yet, but they do come with the battery. As you see, it's a separate battery. It's not actually inside the case. I've already installed the battery for the sake of saving time. They even come with a user manual here and the phone number for support and what have you. Says support is actually in Michigan for this particular one. The user manual is pretty basic, nothing special. I've kind of skimmed it. Interesting fact here, something I did not expect. A certificate of compliance as of October 2014. And take a note on this particular section here. This was actually certificate of compliance for the calibration. Calibration was actually done with a Fluke 5500A Precision MasTech Enterprise Company for Toptronic, marketed by Aven Incorporated Pty Ltd. So this is actually a MasTech, which actually makes sense if you look at the colors of this device. These are definitely MasTech colors. So a remarketed MasTech, we can call this, or practically just a MasTech. Comes in a nice little plastic carrying case here. And let's see how they work. Also, I want to note that it does actually come with a second pair of gold tweezer tips as well, gold plated tweezer tips. So you have a second pair to use as well as the first pair. If for some reason you happen to wear down the first pair of the gold tips for whatever reason. Let's take a look at these gold tips a little closer. They are fairly nice. They do look like they got a light coat of gold. I don't know if they're definitely not solid gold, but they got a good contact with the screws. I don't know why you would have to ever replace those. But let's go ahead and turn this on. There we go. So we're in resistance. We check the resistor. So 9.82 thousand, 9.81 thousand, so just about right on there with what I actually showed on the Flukes. Don't know if you can hear that. It's very snappy on the continuity checker. Very fast actually. Diode checker, auto scan. Okay. I believe the continuity checker is also the dual function. Let's see where'd the capacitor go? Oh, well, there's the NF, so I believe this is the capacitor. So 1 microfarad picks up 1.032 microfarad. A little higher than what I picked up with my Fluke. This one also picking up a little higher, 1.121 microfarad, 1.12 microfarad, just slightly higher, but still within the. These are 5% SMD components here, so they're not exactly really good. So what we're going to do here is let's measure this one on the circuit board here. Let's take a look at this one. This one comes up as 4.92 nanofarads. It's pretty weak for a 1206 capacitor actually. Check it again. There it is, 4.95 nanofarads again. So if I was to bring my Fluke into this, because of course we do want to compare both sides, 4.92 nanofarads. We're still on capacitance here on my Fluke. We'll use the tweezers since the tweezers did prove to be pretty accurate and they're easier to read. My Fluke says it's 5.2 nanofarads. Interesting. 5.2 nanofarads, 5.19 nanofarads versus 4.92, 4.93. So there is a slight difference there. Let's go over to our ohm setting here. See if we can find a resistor that's on the board that's in line with something. Here we go. Take this bottom one. So it's supposed to be a probably 1K resistor, 0.971K. The one above it, 4.65K. I don't think that one's populated. No, there's nothing there. Nope. Okay. 4.66. All of these going up are identical. Ooh, that's interesting. That must be 971K, so 1001K, 970, 969, 969. So they are all identical going up. Check the fluke with the tweezers. .9741. So that's right. This one should have been a higher 4.669. So same reading. And then all of these again are the same going up. 0.9738, 0.9731, 9718, and 9712. So they sound like these are about 10% accurate. SMD 10,000K, 10,000? No, 1,000K for about 5-6 of these. Alright, so we got one more thing here that we need to check, and that is over here, the diode. So let's check the diodes. We have a Zener Diode and more of a standard diode here. One direction is giving me about 1 volt DC. Let's put the positive on the other side of the Zener Diode. And we get a little over a half a volt, 0.6 of a volt DC. We'll do this diode here. 0.6 of a DC, 0.6 of a volt. We'll put the positive on the other side, do a reverse polarity change on the diode. Almost 0.2, 0.19 volt. Let's bring the smart tweezers back in. I don't know what's so smart about them, just seems like I made it with tweezers so far. Here's the Diode Checker. 0.541. Should be closer to 0.6. Now here's the thing about this smart tweezer. It's so smart I can't flip it over because I can't see the display. That's how smart that is. So you have to actually turn your whole board around here. 0.175. I think I got like what, 0.2? Yeah, that's what I thought. Okay, so the Zener Diode of course has much more accuracy for a diode, so let's go ahead and check that this way while I have the board flipped around. 0.882, and I believe it was 0.91 before. And this side should have been about 0.6. This is giving me 0.517. So close, yeah, 516. Don't know if I'd call it a fluke, but of course the question is whether any of these readings were actually accurate on the board in line in the circuit. So now I'm going to remove these same parts. I'm going to remove that diode, the Zener Diode here. I'm going to remove these small resistors here, and I'm going to remove this capacitor, and we will come back and test it outside. In fact, let's check this capacitor here. 4.97 nanofarad, and this is 1 nanofarad. So 1, yep, 1 nanofarad. And I believe again this was 4.97 nanofarad too. Yep, 4.97 nanofarad. Okay. So we'll remove one of these resistors because these all were about the same. And we'll remove one of these caps because all three of these caps, well, 1 nanofarad, half a nanofarad. And then we'll remove these two diodes, and then we'll check them outside off the circuit board to see just how good, inline check was with these versus not inline, and see what the difference is. So I'll be right back. To turn it off, hold down the function, boom, done. To turn this off, hold down the power. Not even hold down, just shut it off. So we'll be right back. Okay, so welcome back. And everything that I said I was going to unsolder, well, there they are. They're dribbled around here somewhere. we have these are the three parts that I said I'd originally test it off circuit. And here we go, we have our caps here. 1, 2, 3. We have our bigger diode, we have our Zener Diode here. We can grab that right, facing the right direction. Let's see if we can turn that around. And we have our smaller resistors. We have two different versions, two different kinds of resistors going on here, so I believe we still have two different kinds of resistors if I'm not mistaken. I made sure I pulled those. I had those under the magnifying glass. So we should get the two different readings that we expected. Let's go ahead and check those first with our smart guy. I'll zoom back out. We'll do the capacitors first. So off the, let's choose capacitance. There we go. So off the circuit we get 1 nanofarad. So this should be 1.5 nanofarads. Whoa, we lost that one. Come back, come back. There we go. Can't get this one to stay still. Oh, that's also 1 nanofarad. I'm pretty sure that came up a 0.5 nanofarad on the board. And this is also 1 nanofarad. Interesting. So, one of these came up a 0.5 nanofarad. Two of these came up a 0.5 nanofarad. So two that came up a 0.5 nanofarad and one that came up 1 nanofarad on the board. These are all proving to be 1 nanofarad off the board.
What were they on?
On, I think they were 0.6. Two of them were 0.6 and one was 1.
There you go.
So the smart resistors that have a picture of testing things on the board, they lie, yes. Let's check out, I'm not going to bother checking with my fluke because the smart resistor, the smart thing is actually telling me something different anyway. Let's go ahead and go over to the Diode Checker. If I can hold this, I'm gonna have to get my hand in here and just hold this still. .75 volts one direction. Let's turn the diode around. And this one comes up as, it's not. It's saying no voltage going through. Yep, I got nothing on that direction. Over limit. Okay, what about the Zener Diode? Let's check this. This direction, 0.5 volt. That's about right. And on this direction, turn it around. Dang, can't get it to stay still. There we go. Nothing. Like a diode's expected to do. Only allow voltage to go through one way. So these actually act correctly off the circuit. On the circuit though, we were actually seeing different voltages depending on which way you held it. And for our resistors, there we go. This one shows up as 4.65 thousand. I'll have to review the video to see what it was in the beginning. This one shows up as, it doesn't, it keeps slipping out of my darn tweezers. Hold on, I might have to assist in some help here. Here we go, got some help. 0.997 thousand. I think that was the same. But you know, I don't even know if it's worth finishing this. 0.996 thousand. Okay. Because we've already proven that the caps themselves were just wrong on circuit. 0.996 thousand. Okay, so 4.64 thousand. 4647. And this one was, I pulled one of each off. 0.997, 7.96,000. Okay. Either way, the diodes act the way they should, off circuit. The caps actually show 1 nanofarad, not 1 nanofarad and 0.6 nanofarad and 0.5 nanofarad. I'm not gonna bother checking it with my fluke because I can tell you right now the inconsistency of on circuit versus off circuit are different. Which these are supposed to be smart, so it's supposed to determine what they are, or at least the picture leads you to believe you're able to check them in circuit and get an accurate reading. That's why they call them smart SMD testers. That's not the case. That's not what I saw. I'm not happy with them. Going back to the store. Done. Now, for the sake of consistency, I know I said I wasn't going to bother checking it with my fluke, but I really should, I guess. So let's bring the fluke back in line here.
It doesn't really matter either way, they're different.
Yeah, I know they're different. We're just gonna check the caps. That's where we saw the biggest difference, right?
Yeah.
So,
How many clicks was it? I changed the settings and I don't know how the fuck I just did it.
so this shows, wow, that shows wrong. That's not even picking up right now, actually. .13 nanofarads, huh? Let me check something. I am on capacitor, yes. What's this show up as? 0.137 nanofarad. That's not even picking up. Let me grab the actual fluke leads. Let's get rid of these tweezers. Give me something pointier to break through that solder.
Inconsistency.
I'm not getting anything. That's the problem there. 1.18 nanofarad. Okay, finally. 1.17 nanofarad. And 1.17 nanofarad. Wow, all these caps are identical. That's awesome. I love the accuracy of this fluke. What do we got here? Diode. Where's my diode checker? Yeah, I don't know either. Ohms. Oh, you know what? It was on the same freaking one as my cap. Okay, so let's get these caps out of the way.
Check something. What do I do with it? There it is.
No voltage this direction. Turn my probes around because it's easier than turning this little piece around. And 0.2 volts the other direction. This is about the same I saw with the so-called smart tweezers, but they're not smart because they weren't able to do it inside, inline, in circuit. .6 of a volt. Turn the diode around and I should get nothing the other direction. Nothing the other direction. What I expected. Great. And finally, if I can get these, actually these are some small resistors. Just popped out of line just as I got the reading figures. Popped out of line again. So you can see it just comes up. So about 1,000 ohms. And this one, 4.6. I really need a pair of glasses for these. $4.6 thousand. 9.9982 9.999199992 thousand ohms. So this story is these smart tweezers gave me voltage on different voltages, different directions, and gave me wrong readings on the capacitors. Yet these little resistors here, well, I believe the resistance was correct. So if you're buying smart tweezers for about 40 bucks and you expect them to work inline circuit for a resistance, that may work. Capacitors will not work. And diodes, you have to know the direction that the actual circuit board is actually running the power for the diode. Otherwise, you'll get different inconsistent readings on different directions. For my book, worth keeping? No, not worth keeping. Going back? Yes, because I can use a pair of probes and a fluke that I know is more accurate and get the same inconsistent reading depending on which direction my probes sit. And yes, that's wrong for the capacitor as well. So thanks for watching. If you like this video, please give it a thumbs up. Please subscribe to see more videos like this. And it looks like I go back to the store to get my 40 bucks back tomorrow.